Today we're going to learn about graphs and their functions. We're going to remember some things from before and just kind of put it all together in one nice package. So the first thing we're going to do with this today is we're just going to kind of look at remembering a few things from before. We have two types of graphs that we're worrying about. So our two types of graphs, one is a discrete graph. And a discrete graph is pretty easy to look at. Now we're not talking whether it's a function, not a function. We don't care about that for this moment. One of the ways it'll look like it, we see these, sometimes we call them scatter plots. So you see a lot of points just kind of scattered around. Or it can look really good, nice and pretty, in a nice pretty line. But we have to remember that a discrete graph is points that don't connect. So they don't connect. So I've got a D and don't, and I've got a D and discrete. That might be one way I might remember it. You can think of points as dots, if that helps you do that. So our discrete graph's a bunch of dots just kind of tossed around. So that would be a discrete graph. The other kind is a continuous graph. So a continuous graph is a little bit different. Here, the points are, wait for it, connected. Woo! So our points are connected, and that's the way I remember it, is that continuous has a C and connected has a C. So continuous, connected. And they can look like a straight line. They can be curvy. They can look like a U. So any of those, as long as the points are connected, that makes it continuous. Not connected, or don't connect, discrete. So that's the two major first things. We got to say whether it is discrete or not. One of the other things that we had to remember is about minimum and maximum values. Well, let's first back up for a second. If something's a function or not, because that's really the meat and potatoes of where we're going with this little video. We have to remember that vertical line test, that thing called a vertical line test. And that was where we take our pencil and we go from left to right across the graph, and if the x's repeat, or we hit 2 points vertically lined up on top of each other, we know it's not a function. So x can't repeat. So when we're thinking about our ordered pairs, the x can't compete. So if we have it like this, remember this is our x, this is our y. And I've got something that looks like this. If I'm looking, going up and down all the way over here, and I look at my ordered pairs, nope, x doesn't repeat. So this is a function. Woo, yay, it's a function. If I take, and it looks like something like this, oh wow, look right here. Right here, if I take my vertical line, there's a point, there's a point, there's a point, there's a point. Oh, the x's repeat on that y-axis, the x's repeat. So therefore, since the x's repeat, it's no, heavens no, not a function. Because when I look at this, and if I were to take my ordered pairs, I would say, oh, the x's repeat right there. They repeat right here. So we're looking at this value. Does it repeat? And it does in both cases. Taking that vertical line and going around. So those are the is it a function or not a function criteria. And one last thing that people get a little bit confused about before we just get into the four types is this thing called a maximum and a minimum value. And people, for some reason, have a really hard time twisting this in their brains. So if we have a function, and this only applies on if it's a function or not a function, and we have something that looks like this, we can see that this point on the y-axis, there's no other points that are going to be bigger than this point. So that is our maximum value. No y bigger than that point. I don't have any real little good tricks for this one, but you just have to remember that if it opens up facing down, it's going to have a maximum. So therefore, if it opens up facing up this way, it's going to have a minimum. I can't think of a really great way to give you a trick to remember that, but opening it up is a minimum, opening down is a maximum. So there's no y bigger, smaller than that point. So minimum, everything is smaller. Maximum, everything is bigger than the point that we have without, where it crosses and makes that cute little U or V. So now we'll look at our 4 types of functions that we have to be able to identify for this unit. Our first one is linear. And linear, this one's pretty easy. Makes a straight being important. But here's how the trick to remember it. Line. There you go. Line and line. Linear line. It can increase or decrease. We've seen that. Linear is the one you're most familiar with. We've been dealing with linear equations for the last couple of years. It can be discrete or continuous. Either one. It's not going to be both, obviously, at the same time, but it'll be either one. And the way you're going to see that written, and this is probably the first time you've seen function notation, but this is really just, we say it's f of x, the function of x, which is just another way of saying y, but with fancy algebra words. So f of x equals, or our answer, mx plus b. Woo, look at that, that's slope. We know slope makes a straight line, right? So there's our slope formula. F of x equals x plus 1, and these are just a few examples. It could even just equal x. So when we draw it, when we put it in our graphing calculator and we draw it, it's just going to be a straight line. And we know for deciding if it's increasing, decreasing, what, we start over here at the left and we go this way. So we notice starting here it goes up. So that means this one is increasing. And I'm going to put that over here so we remember that, increasing. And remember I said it could be discrete or continuous, so we're going to do this one as discrete. Now look at reading, just like reading a book, left to right. If I start here and I go along, I'm like, ooh, it's going down. So this one is decreasing. And we need to know that just because we need to know it, but I also know there's a question on the test that deals with that. So we want to make sure we know increasing and decreasing. So the next one, linear is probably the most one we're familiar with, but the next one is our quadratic functions. And when we have quadratic functions and we draw them out, it's going to make the letter U. And this is my little trick for remembering quadratic and what the graph looks like. It's a U, and lo and behold, there's a U in quadratic. So U quadratic, it can increase, then decrease, or it will decrease, then increase. It has either a minimum, I can't spell, minimum, or maximum value. So it's got either or. It will look something like this. Remember, it forms a U. Or it's going to look something like this. And remember, we said you can't go this way. So it's going to either open up or down, never sideways. So looking at this one, we know everything is bigger. So this is our minimum. And looking at it this way, going back to what we talked about, this is our maximum. Now I notice there's a curve to it, right? It's not a perfectly straight line, so it's made up of a curve. And if you look back to our increasing and decreasing reading left to right, if I start here, it goes down and then it goes back up. So it's decreasing, then increasing. Over here, if you look at this one, reading left to right on our graph, it's going up, then it's going back down. So it's increasing and then decreasing. And the way you're going to see this one written, we'll have our f of x, and it'll equal x squared. Here's some more examples. F of x equals 2x squared plus 4x plus 8. F of x equals 2x squared minus 10. Those are just some examples, but this is the important part to remember, that the biggest exponent that you're going to have involved with these is going to be a square. You won't have a cube because then we have a cubic function. You'll only have a square for that. So our next one, and remember, if you're trying to take down some of these notes, you can always pause the tape, do whatever you need to do. Absolute value function. Now this one is a dead giveaway. So easy to tell from the drawing, as the graph itself, as well as the equation, because we remember when we learned back, I think in 6th grade, about absolute value. You're going to see those absolute value bars. When you see those two parallel lines that make those absolute value bars, you're instantly going to go, woo, woo, that's an absolute value function. Woo, woo, that's an absolute value function. So, other examples look like this. And still others look like this, because you can have it on the outside. But in each case, you see those absolute value bars. Graphically, oh, so easy. Graphically. Remember with our quadratic, it made that pretty little u? This one makes a V for victory, for value. So, easiest way to remember that is a V. And we got that fancy V in value. Absolute value is going to make a V when we draw it out. It also increases and decreases, or it decreases and increases. So it'll do both. It, just like the quadratic, has a min and a max. So far, linear is the only one that does not. I don't know if we mentioned that, but the linear function does not have a minimum or maximum, obviously, because it doesn't make a point, right? It goes on and on and on and on. And in this case, our quadratic made that curvy U. This one's going to be made of straight lines. Just think how you write a V. We don't write it with wussy little lines. We write it with nice, sharp, straight lines. So when we look at this, we're going to have our V like that. That's one of our absolute value functions, or we're going to have one that looks like that. And when we do this, notice everything is bigger. So this is our min, and in this case, everything is smaller. So this is going to be our max. So we have one last function that we have to worry about. So far we've got those linear lines. We've got the quadratics that make a u and have an x squared somewhere in there. We have our absolute value function, which makes a v and has those absolute value bars. And the last, but certainly not the least, is our exponential. Now you're going to be like, Mrs. O'Neill, a square is an exponent. Well, this is a little bit different than what you're thinking about with that x squared. And we studied cubics before, and cubics have that x to the third power. So this one looks a little bit different. And that's why it should stick into your brain. So it's going to look something like this. You'll have your f of x. And this is how we like to say things algebraically, right? Here is where you're going to find the exponent. The exponent is going to be raised. The x is going to be there. So our x is going to be here rather than as part of the problem. So another way you might see it would be like this. Or you might have one that looks like this. it's going to be this part is where your x is going to be. That's not going to be anything but an x there. So it can increase or decrease, not at the same time. It does not. This is the other one. So when you're studying, remember there's 2 that have a minimum and maximum and 2 that do not. Does not have a minimum or maximum value. And it actually kind of makes it's made up of smooth curves. And where we see this function the most is in science. And you might have actually seen it in some of your science classes already. So when we talk about decay and things like that, that's where you see this. So it starts out and then it curves up. Or if we're talking about decay, which is something we see in science, it might start out here and then go down. So you're going to start out with a little bit and then all of a sudden it increases and increases and increases, or decreases and decreases and decreases to make almost what turns out, it never turns into a straight line, but it gets smaller and smaller and smaller and more finite. So these don't have a min or max, and they also make this cute little squirt curve. So it looks a little bit different than anything else that we've seen up until today. So those are the 4 main types that we're going to be worrying about for this unit. So please feel free to look this over and make sure you know it for the test.